Hello guys, welcome to today's video. Today we are going to do the part 2 of the first chapter that we had started in the previous video, that is some basic concepts of chemistry. In the last video I have just introduced the chapter. We have just discussed what is chemistry, significant figures, exponential notations, addition, subtraction, rules, right? Then the different periods of chemistry and all that things we have done, classification of matter, universe made up of matter and energy, that we have discussed. Today we are going to do is the next part, very important part, laws of chemical combinations, Avogadro Hypothesis, Berzelius Hypothesis, okay, and Dalton's atomic theory. So first we will add dimensional analysis as well. First we'll begin with the physical quantities. Now we'll find few pages devoted to this topic. You already know what are physical quantities. Quantities which can be measured. Any quantity that can be measured is a physical quantity. Now physical quantity is not one, divided into two categories, right? You already know that it's derived, it's basic, fundamental, right? So basic, you know there are 7 basic physical quantities, 7 in number, right? Individually we'll just go through the SI units and the name. Definition is also there, it is not asked. Okay, so what are the 7 you have? You have is unit of length, mass, time, temperature, amount of substance, electric current, intensity, luminous intensity. Okay, respective units you need to study. Then you have is derived. Derived means from basic you are deriving them, so they are derived. You have many, I am just naming a few. Area you have, acceleration you have, energy you have. Okay, lot of many are there, so you have to just go through the units. Okay, volume you have, velocity you have, density is there, force is there, pressure is there, energy, plane angle, solid angle, frequency, power, electric charge, electric potential. Okay, so these are the things you are going to read under the derived category. Okay, units is very important. Units, which physical quantity is having what unit, that you need to know, very important. Okay, so this was nothing, it's a very easy one. You already learned in previous classes as well what are physical quantities and all that. Now let's move on to one of the important topics that you need to read, that is dimensional analysis. This is called dimensional analysis. Sounding is, what to say. People think that by the name only it's very difficult. It's not at all difficult. What is dimensional analysis? Is basically used for conversion. Conversion from one unit to another unit. Okay. Now you can do conversion normally, but you have a high chance of making a mistake. I am not saying you cannot do, you can do, but you have a chance of making mistake. But if you use dimensional analysis, you cannot make any mistake. You will automatically find out if you are making any mistake or not. Okay, let's take one example. Suppose you have is 50 kg and you need to convert it into gram, not gram, leave it, mg. You have 50 kg weight, you need to convert it into milligram. You know the relation between kg and mg, that's 10 to the power 6, and since we are going from bigger to smaller, we will multiply. So answer is supposed to be this. Everyone knows that. Fine, no problem. This was a very, zeros are very easy to sort out. But if you are having problem in doing that, then what will you do? Will you do dimensional analysis? But for dimensional analysis as well, you need to know the relation between the units. Like 1 kg is equal to how many milligram, that you need to know. Clear or not clear? How much kg is equal to 10 to the power 6 milligram, that you need to know. Right, so 1 kg is 10 to the power 6 milligram. That you need to know, otherwise you cannot apply dimensional analysis. Okay. So we can write 1 kg is 10 to the power 6 milligram. Now 1 equal to 10 to the power 6 milligram divided by 1 kg. Can I write it? This particular step. This is an important step if you are doing dimension analysis. This is called conversion factor. What factor are you converting? This is the conversion factor. Now in place of this one, you will be writing this value. Now if you put this value, you find kg and kg will cancel out. Remaining will be this into this. Clear? So in case of dimensional analysis, you do not have a chance of making any error. If you make an error, you will get to see the error. So this is dimensional analysis. You need to write the conversion factor. Then you multiply, divide, whatever you want to do. But you first write the conversion factor. Clear? Understood? This is dimensional analysis. Okay, now note down a few important things that you need to memorize. You will need it throughout chemistry. You will need it. What is it? Mega, kilo. Can you understand what is this? Prefix. Right? These are prefix. So mega, kilo. These are some important things you need to remember. Then milli, micro. They are represented by mu also. Okay, pico. These are the most commonly used units you will get. These are the most commonly used units you will get. One more is there. Nano. These are all the most widely used units. You go for wavelength calculation, in atomic structure, all where you will get in nanometer or picometer or micrometer, that is micron as well, millimeter. Okay, so you need to remember what is the relation with the SI unit of this prefix. This prefix, they have got a particular relation. This relation needs to be memorized. Clear or not clear? So mega, it is 10 to the power 6 positive. Kilo is 10 to the power 3. Now it is kilogram, meter or whatever it is, that depends on what is the question. Milli is 10 to the power minus 3. Milli is 10 to the power minus 3. After milli comes micro, 10 to the power minus 6. This will go up, okay, this will come down. After micro comes nano, 10 to the power minus 9. And this comes further. So you can see the gradual transition is of 3, 3, 3, 3, 3. Can you notice it? The gradual transition is of 3. In between kilo and milli, you will get is the original value, the SI unit. If it is kilogram, then it will be gram. That is 0. Okay. So see, everyone is having 3 transitions. 6, 3, minus 3, minus 6, minus 9, minus 12. Clear? So who is coming first in this list? Mega, then kilo, then milli, then micro, then nano, then pico. Don't think this is the end. Lot more are there. Okay. Femto is there, Yocto is there, Zepto is there, Yocto is there. Lot of things are there, but we are not going to deal with it because we don't use it often. These are the most often things that we use. Clear? So this you need to remember. In case of dimensional analysis also you might need it, and in other numericals also you will need it. Clear? Done? Okay. Now we are moving on to the important parts. Let us start with Dalton's atomic theory. Dalton's atomic theory. Now this theory, you have read it in our previous classes as well, that John Dalton, he gave a theory which stated that atoms are indestructible. You cannot destroy an atom. You cannot divide an atom. Atoms are the unit of chemical reactions. Atom of one element will be different from that of other element. Then, if there is one element, then all its atoms will be similar or identical in all respects you take. Right or wrong? Right. Atoms of different elements will be combining together to form compound atoms. The term is compound atoms. Remember, if you are writing Dalton's atomic theory, do not use the term molecule, because the term molecule was not given by Dalton. The term molecule was given by Avogadro. It will be coming later on, not now. Dalton gave the term atom, not molecule. It was given by Avogadro. Clear? So you will be stating the term compound atom. So what did Dalton say? Dalton said that atoms of one element combined with other element in simple fixed whole number ratio to form compound atoms. Clear or not clear? I am not writing it because you have already learned it many times. Most important points, postulates of Dalton's atomic theory. Generally, I will say that not to skip any postulate, but still, the most important postulates are indestructible, that is, you cannot destroy an atom; indivisible, you cannot divide an atom, which is now not true, I know. Then you have is identical in all respect, one similar atom or one atom. Then one element's atoms is different from other element's atoms. Then atoms of one element will be combining with atoms of other element in fixed simple whole number ratio to form compound atoms. So you can see more or less all the postulates are important. So you cannot skip a postulate because this is a theory. Clear or not clear? Now, if there is a law, then it will definitely have some limitations. So what are the limitations of this particular theory? Dalton's theory. Limitation number 1, did not explain Gay-Lussac's law of gaseous volumes or combining volumes. Did not explain. What is Gay-Lussac's law now? We'll be coming to it when we read the law of chemical combination just sometimes after. Okay, so hold on for some time. Next, Dalton's atomic theory could not explain why will atoms combine. Why? What is the reason? Stability or something that did not that was not stated actually by Dalton. It was stated later on by Bohr, Rutherford, all that. Okay, so why and how they will form compound atoms was not stated by Dalton. Clear? Then you have is, if atoms are forming compound atoms, then how are atoms in a compound atom held? Someone is holding them, some force is holding them. What is holding them exactly is not known. So this was another limitation of this law. It could not state what exactly is holding the atoms in a compound atom. Clear? Last one you have is, why atoms cannot exist in free state and why compound atoms can exist freely. This could also Dalton could not state. So these are all the limitations of Dalton's atomic theory. What is the current position of the Dalton's atomic theory? Very few of the postulates are still holding true. Postulate that is holding true is that atom is the smallest particle which cannot exist in free state. Then you have this the second postulate that is stated that atoms of an element in all respect is identical, but it is not true. Why? Due to this term. What is this? Isotope. What are isotopes? Atomic number remains same, mass number will change. Hydrogen, protium, deuterium, tritium, right? They all are the same element, hydrogen, but the mass numbers are different. So are their atoms same in all respects? No. The nucleons are different, so all respects they are not same. So this postulate breaks over here. Clear? Then Dalton said that atoms of one element is different from that of other element. Another term comes up here. That's isobars. What are isobars? Atomic number is different, but mass number is same. So atoms of one element is identical to other element in terms of its mass number. So this postulate also breaks up. Next, Dalton said you cannot divide an atom, but we have divided an atom into proton, electron, neutron, even now meson, no, antineutrino, lot of things are there. Then Dalton said you cannot destroy an atom. That is also not true. Why? Because our favorite Mr. Einstein is there to state that E is equal to mc square. So atom is destructible. Clear? Then atom was told to be the unit of chemical reaction by Dalton, and that is correct, valid. Till now it is valid. Don't know what will happen in future, but right now it is a valid one. Another postulate that is valid is that Dalton said that atoms of an element will combine with other element in a simple fixed whole number ratio to form compound atoms. That is also holding true. Okay, hydrogen will combine with water in a fixed ratio, right? Cannot combine in any random ratio and form water. Can it? Cannot. So this postulate also holds true. So two of the postulates we have seen is holding true, rest are not holding true. Clear? Sorry, three, not two. Clear or not clear? This is Dalton's atomic theory. So we are just going to go through the postulates. What is the current position of Dalton's atomic theory? Clear? If you can give it a thorough reading, it's very easy to remember. Done? Now we are moving on to the important topic, laws of chemical combinations. Laws of chemical combination. Laws of chemical combination. Under this, we will be studying 5 different laws. Clear? These are the basic laws that govern chemistry. Clear? That govern the chemical combinations. How an element will combine, with a chemical will combine, what ratio they will do it, all are governed by this 5 set of different rules. Out of which the first rule we are going to study is going to be the law of conservation of mass. The law of conservation of mass you have read in many classes, right? Many classes you have read. So what exactly the law of conservation of conservation of mass state that during a chemical reaction mass is neither destroyed nor it is created. Clear or not clear? Clear or not clear? Now we do not write mass, as I've already told you in the case when I was what to say, I was dividing universe into matter and energy. I first wrote mass, then I said that better way of representing mass will be matter, because something that has mass will also occupy some volume. So instead of writing mass, we should mention matter. So in this case also the same thing we are going to apply. In a chemical reaction, matter we will write. Instead of mass, we will write the word matter. So in a chemical reaction, matter can neither be created nor be destroyed. It can only change from one form to the another. This is law of conservation of mass. Who proposed it? It's a very important thing. The statement is obviously important. It was stated by the father of chemistry, Lavoisier. Lavoisier. Right, it was proposed by Antoine Lavoisier. Here is not needed. Now, example, so I am not giving you. You already know what is the example. Thousands of reactions you all know. Put any and show. Clear. Don't put complex. Put simple reaction. Okay. Now in your book you will find one term, experimental verification of this. All the laws, there will be an experimental verification. So this experimental verification for law of conservation of mass is done using a Landau's tube. Clear? What is it called? Landau's tube. It's a kind of H-shaped tube. Okay, H-shaped tube. How does it look like exactly? It's, what is an H? H is like this. Okay, this tube is exactly like this. My drawing is very bad, don't judge it. This is like this. Okay, here one solution, here one solution. When they are shaken, some will pass from here and here, some reaction will occur. Okay, clear? Mass is checked when at the beginning and again mass is checked at the end. We'll find that it is same. So verified. Next, you come. Next, what is the present day condition of this law of conservation of mass? This law of conservation of mass holds good in all the simple reactions. Simple. Why did I use the word simple? I will tell you. Just let me tell this. This law holds good in all the simple reactions that is there in chemistry. Okay. Now, what do I mean by complex reaction? Complex reaction means there is a lot of change in the state, lot of change in the energy. Clear? As you already know, Einstein's mass energy relation equal to mc square. So mass can be changed to energy. So in that case, if the mass goes to energy, then how will you measure that? Can you measure if mass changes to energy? Then in that case, this law will not stand valid. So this exception for this law is limited to simple chemical reaction where this change of mass energy is not involved. Clear? The normal reactions where there is no change of mass energy, this law is well valid. Clear or not clear? So this tube is Landau's tube where you will be checking out this law of chemical combinations. First law of conservation of mass. Clear? Now we are moving on to the second law. Second law is law of definite proportion. This is also called as law of constant composition. Law of definite proportion. Okay, exact statement you will get from your book. Okay, I'm not saying the exact statement, I'm just making you understand. Exact statement you will get from your book. Definite proportion, this means from wherever you take the element, from wherever you take the sample, their mass ratio will be same. Did you understand? Do not write this. Do not write this in the statement. This is not the statement. Just telling you, I'm just explaining you. Okay, from wherever you take a sample, the mass ratio will be same. Definite proportion by mass, the elements will be combined. Okay, suppose water, rainwater, drop falling, you are taking that water. Fine, very good. Well, river, that water you are taking. Well, very good. There you have is groundwater. Okay, this is ground, and below ground there is water. You are taking that water. All these are water only. So what do you expect? Will the chemical composition different? No. I am not talking about mixture. That is impurity. I am not talking about impurity. I am talking about chemical composition of water will be different or not. Chemical composition of water will be different. H2O will remain H2O. What is the ratio? 2:16. 1:8. No matter you take from rainwater, river water, groundwater, sea water, surface water, ocean water. All these will have hydrogen oxygen combined in 1:8 ratio only. Right? This is what the law of definite proportion states. It's also called law of constant composition. So from wherever source you take, they are combining atoms or combining elements will be in a definite proportion by mass. Clear or not clear? For the exact statement, please refer to your book. I am just telling to explain you, do not write this in the statement cases. Next, experimental verification. This law was experimentally verification was done by Stas. Clear? Another scientist, Stas. He did his try to make carbon dioxide by different sources, but all of them had the same ratio in combination. Clear? 12:32. Okay. Present day, same exception comes over here, but not equal to mc square, a little bit different. Now see, this is H2O. Well, 2:16 because hydrogen has one mass. Now, if I say that this water is combined, is made from hydrogen that has 2 mass, that means deuterium, not protium, deuterium, then this will change into 4:16, is 1:4. Now tell me, did you understand something? So if some specified isotope is not mentioned, then this law will not hold good. Clear? When isotopes came into existence by Soddy is invented, discovered, not invented actually, discovered isotopes, then this law was not holding good, because obviously the ratio will change because the mass has changed. Right or wrong? So this is a limitation. So you have to check out the relay. Okay, limitation. Okay, next we are moving on to the third law. Third law, that is, we'll just change one word over here. The finite proportion, now this time it is. Now you'll say, oh, what? Just now we did definite, now why it is multiple? That this is Dalton. This was proposed by Mr. Dalton, John Dalton. What did he say? He said that whenever two or more elements, not two or more to hobe na, it's two elements, let's take it right now. Two elements will be combining to form more than one compound. Then the different masses of one element that will combining with the other element's fixed mass will be in the ratio of simple whole number. Clear? Did not understand? Let's explain. Suppose you have is this and you have is this. Same element? Compound is same? No, compound is different. Here ratio 14:16. Here ratio 14:32. So, as far as the statement says, when two elements combine to form more than one compound, then the ratio is in a whole number. Ratio of what is in a whole number? Ratio of one element different mass combining with the fixed mass of other element. This ratio will be in the whole number. Now understand. Here this is 14, this is also 14. So this combination is 16, this is 32. Ratio is 16:32. That's 1:2. Are is in a whole number? Yes. Both are combining with the same mass, 14. Even if you take 14x, let's say 14x only. Here, both are combining with the same mass. What is the ratio? 16:32. That is 1:2. Done. So this is in the whole number. So this is what Dalton said by this law of multiple proportions. Understood or not understood? Understood or not understood? Then you have his experimental verification, and you can check it out by the metals which are having variable valencies. Okay. Next is your limitation. Limitation again remains the same until and unless the isotopic specified form of an element is mentioned. This law will not hold good. Clear or not clear? Clear? Very good. Now we are moving on to the fourth law. Fourth law and the most important law. Again I will change one word only. The proportion will remain the same. Very important law. What is the law? Law of reciprocal proportions. Law of reciprocal proportion. Now this law, is a confusing one if you do not understand properly. This is a very confusing one if you cannot understand properly. This law was proposed by Richter. Clear? Not the Richter scale, it's Richter. Okay. This law was proposed by Richter. This law states that when two elements combine separately, So first is two elements. They are combining separately with the third element. Two elements combining separately with the fixed mass or the definite mass of third element. Then the ratio of their masses, in which they will do that, that means combined with the fixed mass of third element, will be in the same whole number ratio or maybe a multiple of what they combine with each other by mass. মাথার উপর দিয়ে গেল কিছু মনে হচ্ছে. Let's see. Hydrogen, sulfur, oxygen. These are the 3%. Okay, 3 elements are there. Any problem is there? No problem. 3 elements are there. Well, now we'll be considering this oxygen guy as a third element. Okay. So law states that when two elements individually combine with the third element, hydrogen will combine with oxygen to form which compound? Water. Sulfur will consider characteristic sulfur dioxide, the most stable one, sulfur dioxide. So this will form H2S. Now according to the law, when they will combine individually, what is the ratio? This 2 is to 60, 1 is to 8. Here, what is the ratio? This is 1 is to 1. Or I can say, do not write 1 is to 8 right now, because it will be, seeing why not. 32 is to 32. Very good. This is how much? 2 is to 32. Now what does the law say? When two elements will individually combine with the fixed mass of third element. Can you see the fixed mass? These two elements are combining with the fixed mass? No. This is 16, 32. So I have to make it 16 over here. So if I want to make it 32, then I will multiply it by 2. So this will become 4. Okay. This will become 4. So what is the ratio? Ratio is 4 is to 32. Am I correct? This is becoming 4 and this is 32. So the ratio in which they are combining with the third element is 4 is to 32. That I can say it as 1 is to 8 now. Now it is said that the ratio in which they combine with the third element will be the whole number ratio or the multiple. Same whole number ratio, the multiple of the thing they do. That means this ratio and this ratio. If you do, it will be the same simple whole number ratio. Let's take it out. This is 1 is to 16. So 1 is to 16 and 1 is to 8. 1 is to 16 and 1 is to 8. Divide it. What will you get? 2 is to 1. 2 is to 1. Seeing though. 2 is to 1. Clear? 1 by 16 to 8. 2 is to 1. Understood? So 2 is to 1 is a whole simple whole number ratio. This is law of reciprocal proportion. Might it is a very confusing one. I can understand. Understood or not understood? This is the law of reciprocal proportion. Explaining once again the law of reciprocal proportion. Same example I am stating again. I know it's a little bit confusing. We have taken 3 elements because the law states 3 elements. So we have taken 3 elements. What are the 3 elements? Hydrogen, sulfur, oxygen. 3 elements, out of which 2 elements will be combining with a fixed mass of third element. We have taken third element oxygen. So hydrogen over here, sulfur over here, hydrogen with oxygen, H2O, sulfur with oxygen, SO2. Ratio 2 is to 16. Ratio 32 is to 32. Here they will form H2S. Ratio 2 is to 32. Theorem states, not theorem actually, sorry, law states that ratio of their masses in which they do so is either the same or whole number multiple of the ratio in which they combine with each other. Correct? That means fixed mass of oxygen we have to take. Is the ratio of, is the mass fixed? No. So we will be multiplying this with 2. So it becomes 4 is to 32. Now it is same. So what is the ratio? 4 is to 32. Clear? Ratio is 1 is to 8. So this ratio and this ratio must be the simple whole number. Clear? So let's take it out. This is 1 is to 16. Okay. So 1 is to 8 and 1 is to 16. So So 1 by 8 into 16. That is 2:1. Done. Simple number ratio. This is law of reciprocal proportion. This was given by Richa. Later on, we have seen that this has stood, what to say. No, what to say. It is true. Okay. No exceptions are there right now at this moment. Clear? Any confusions? I don't think any confusion should be left. What we are going to consider is 3 elements will be given to you in the question. You will be checking on the 3 elements. You will be taking one element as the third element. Even you could have taken here oxygen as the sulfur the third element. No problem is there. The answer will be, ratio might come a little bit different, but answer will be okay. Okay, until you make any error. Clear? This is law of reciprocal proportions. Done? Understood? Next you have is Berzelius law of combining volumes or gaseous volumes. Berzelius law of combining volumes. This was stated by Berzelius himself. Berzelius law of combining they said that when two or more gases react with each other, their volumes will bear a simple whole number ratio to each other and also to the volume of the gaseous product that will be formed. Only condition that you need to check it out is that the physical conditions will remain same. That means temperature, pressure, that should remain the same. Clear? So these conditions should remain same. Understood or not understood? Any example you can take? Any example? Let's take it out. This you already have read in your chapter set of compounds, hydrogen chloride. Okay, this is a gas. This is also a gas. This is also a gas. It is also a gas. Ratio 1, 1. Ratio means here it is coefficients you are going to consider. 1, 1. So ratio is simple whole number ratio. Clear? Can you balance everything by writing half? Very complex reaction, though they are not gases also. Clear? So if there is a solid in between or a liquid, it will be considered 0. When you have done the calculation in class 10 regarding this Berzelius law, then you have considered solid gas volume as 0. We will be working on only the volume of gases because this is Berzelius law of combining volumes of gases, that is gaseous volumes. Clear or not clear? Okay. This was the last law of chemical combination. Now we are moving on to the last two topics of this video, that is Berzelius Hypothesis. This person gave an hypothesis, that means an advice. Okay, hypothesis indicates an advice, not a law, because it has no proof. Hypothesis is an advice, no law, because it has got no proof. Clear? This person said that under conditions of STP, here please note down, S is not equal to standard. S is similar. I am writing. S is similar conditions of temperature and pressure. Okay. Equal volumes of all gases consist of same number of atoms. This was stated by Berzelius. You can understand that Avogadro has just modified the statement atoms to molecules. That's it. Now, did you understand? Under conditions of similar temperature and pressure, equal volumes of all gases will consist of the same number of atoms. Is it possible? It is not possible. Not possible. How? Why? Now let's check it out. Why it is not possible? Let's check it out. Why it is not possible. Let's write the same reaction we wrote some time back. What was the reaction? H2 plus Cl2 2HCl. Right? One volume each. One volume each. 1, 1, 2. Very good. N. N is atoms. N is atoms. 2N atoms. Dividing by N. 1 atom. 1 atom. 2 atoms. They're actually compound atoms. But that is not our factor right now. Okay. I have to make this 1. So this will become half atom plus half atom equal to 1 atom. Is it a compound atom? Now, atom has got divided. Atom has got divided. No longer the unit of chemical reaction. Not good. Going against Dalton's theory, which has been proved that atoms is the unit of chemical reaction. So, half atom is not possible. So, Berzelius hypothesis is rejected. Clear? Atom is divided. Imagine the condition. Atom is divided. So, it is not possible. So, this particular hypothesis or advice was rejected. Following this hypothesis, we come to see Avogadro hypothesis. Avogadro hypothesis. Another person who advised. I am not writing the statement again because it's the same statement. Under conditions of similar conditions of temperature, pressure, equal volume of all gases will have the equal number of molecules and the same number of molecules. Molecules, not atoms. This was stated by Avogadro. Okay. Now let's apply that to the reaction. H2 plus Cl2, 2HCl, 1, 1, 2. These are all volumes. Okay. Okay. N molecules plus N molecules, 2 molecules, 1 molecule plus 1 molecule forms 2 molecules. Oh, sorry, N. Right. So here half a molecule plus half a molecule, 1 molecule. So a molecule is getting divided, not the atom. So atom is still the unit of chemical reaction. Now from Avogadro hypothesis, you can get out the molecular formula, the atomicity. Clear? What is atomicity? Number of atoms present in one molecule of the compound or element or a substance rather. Now here hydrogen is combined with chlorine to form this. It was found HCl is monobasic and all hydrogens are present is replaceable. So if half molecule of hydrogen is participating in this percent formation, then one atom of hydrogen must contain, one molecule of hydrogen must contain 2 atoms. So hydrogen's atomicity is 2. Clear? Like this you are going to get out the values. Alright. You have permission of water vapor in your book. Just you can check it out from the book. Clear or not clear? Okay. Then we will get to know is nitrogen is having 2. Hydrogen is also having 2. From there, if half molecule and 3 by 2 molecule is forming 1 molecule, then 1 plus 3 atom will be forming 1 molecule. So 1 molecule will contain NH3. That will be the formula. Like this, we will be getting the formula. Right. Suppose here hydrogen is Diatomic we already know. This is also diatomic we already know. Half molecule means one atom plus one atom. Okay, one atom plus one atom, one molecule. So what can be the possible formula? HCl only. So this is how you are going to determine the formula using Avogadro's law. Okay, so that's all from this video. In this video we have discussed about Avogadro hypothesis, Berzelius hypothesis, dimension analysis, laws of chemical combinations, and basic physical quantities. In the next video we will be moving on to the next topic about the you know um, classifications. A few mixtures are left that we'll do. Then we are going to move on to the mass, atomic mass, relative atomic mass, and all that, chemical equivalence, and all that related things. Okay, so see you all in the next video. Hope that you have watched this video and you have liked it.